get ready for our main activity for today. So today we're learning to use problem solving and reasoning skills when answering questions about data. So we've got our data on our line graphs, or actually we're going to be dipping our toe again into pie charts. So we've got a special kind of line graph on the board at the moment, and as you can see, it's got a very steady line going up, 45-degree angle. So it's telling us and converting pounds into kilograms and vice versa. So look at the x-axis. What's on the x-axis?
Pounds.
Pounds in weight, we're talking, not pounds in money. And the y-axis we have got?
Kilograms.
Kilograms, thank you. Excellent. And these sort of graphs are really good for finding out, well, what does it equal to? Okay, so if we're looking, we've got some red lines here. So here we've got a 2 pounds, and you follow it directly up. This is where, again, a straight edge or ruler would be really helpful against the graph. Up in the vertical position where it hits that line, you can then take it to the horizontal position, follow that line across to get to your scale on the y-axis. Then you'll be able to read it. It's not quite one, look, kilogram. So there you'd have to use your approximation skills to think about, well, that halfway would be 0.5. So it would be more than 0.5, less than 1 to give your actual amount. So what do you think it might be?
0.9 kilograms.
0.9? I think so. Okay, so that would be an approximation of how we would be converting from pounds to kilograms. However, likewise, if you look, those arrows could be going the other way. So if you're looking at 2 kilograms, what does 2 kilograms in pounds equal to? So again, we're taking it across, this time the horizontal first, where it hits the line of conversion, then you change it to a vertical position, bringing it down, straight down, and there you can see it's hitting the x-axis at this point. So what do you think that reading would be?
About 4.4 pounds.
About 4.4, yeah, I would agree with that, because it's not quite halfway between the 4 and the 5, so it's not 4.5. 4.4 I think would be an accurate measure. Well done. Okay, so here we've got a conversion line graph for pounds and kilograms. What other things could you convert? Any other ideas? What other things might be in a conversion line graph? Yes?
Pounds and pence?
Not, well, I suppose it could be if it was, yes, I suppose you could do if you do over the 100, yeah?
Pounds and ounces?
Pounds and ounces, yes, again. But they are the same unit of measure, but you'll be looking at, one will be a lot bigger than the other to do a bit like grams and kilograms, wouldn't it? Yeah. Oh, perfect. So grams and kilograms. Yes?
Centimetres and metres?
Yeah, you could, yeah.
Kilometres and miles?
Yeah, kilometres and miles. So there you've got 2 different types of measure there, definitely, different units. Any other ideas? What about money? You can have your euros against your pounds. Yeah, to convert.
Dollars against euros?
Or dollars against euros, absolutely. Okay, so that will be useful in that case. So there are a couple of follow-up questions. I think Chile 1 and Chile 2 are going to be looking at conversion line graphs for you today. Okay, the other 2 Chiles are going to be looking at pie graphs. So here's a couple of examples. I know yesterday we found it really tricky, particularly because when the second parts of the question we're looking at degrees of angles within the shape of a circle, which we haven't quite done yet. And so some of you, your year 6s, might remember this from last year. If you don't worry, because we're going to be coming forward in the next couple of weeks to do some more work on shape and angles in particular. Okay, so bear with it at the moment. So here we've got 150 children voted for their favourite ice cream flavours. And here are the results. So just take in for a minute, what is that information telling you? Take a look at the labels. At the top we've got our label, favourite ice cream flavours, and on the side we've got our key. So we've got strawberry, banana, chocolate, vanilla and mint choc. These are in different colours. Also on this pie graph we have got percentages. Okay, and that's key, what we're going to be knowing about, and drawing upon our knowledge what we know about percentages. So, first question, how many people voted for vanilla? So vanilla, the first job, what you've got to do? Yes?
You've got to look on the
Yeah, so you're looking at what colour is vanilla. Looking down, vanilla is the blue. So we're looking at that piece there. So that piece is telling us now we know a percentage. What is it?
15. 15 children.
Oh, sorry. So what percentage is it?
10.
10%. So 10%. So we've got to find out what 10% of 150 is. Now, if you know this really quickly, because if you use your place value chart, if you remember when we are finding 10%, you are dividing by 10. So all the digits are shifting. How many places to the left? Not to the left, to the right. One place because it's getting smaller. Okay, so 10% of 150 is
15.
15. So we now know that 15 children liked vanilla. Now, once we've got that 10%, it's a bit like a ready reckoner. Once you know that 10% is key because it can release the other information for other questions. So how many more people voted for chocolate than mint choc chip? Now think about this one. We've got to think about two bits of information. So what are we going to do first? What percentage is chocolate? How many people like the chocolate? Yeah,
30%.
30%. So chocolate is this grey, 30%. So chocolate, 30. Let's write that down. Okay. Then we've got mint choc chip. Looking at the colour for mint choc chip, we're going for green. Mint choc chip is 20%. What did I just say?
20%.
Okay. So how many more? So we're looking at percentage-wise, aren't we? So we can either convert it first. So there's two methods. You can convert it first into numbers and then make that comparison of difference, or you could do the difference in percentages and then find out what that value would be. So there's two methods. What method did you use? Yeah.
I use the difference in percentages, so I know
Okay.
there's a difference of 10%,
Yeah.
and 10% of 150 is 15, so I know that the difference is 15.
So 10% of 150, which we know is equal to 15. Okay, so that's 15 children. Okay, it's really important to keep the context because otherwise you start to lose the information if you do lots and lots of steps. Did anybody look at the other method? No? Okay, but you can do it. Can anyone walk it through and talk it through what the other method would be? Yes?
So you would find out 20%, but since we know 10% is 15, you times it by 2,
Yeah.
which would be 50.
So that
I mean
20%
30.
would be 30, whereas 30% would be,
15 more,
so it would be
which is 45.
45 children.
And there's a difference of 15 between that since
Yeah.
we added 15
so
onto
45
30.
subtract 30 children is your 15 children. They give you the same way, it's just a different method of getting there. Okay, next on the question. How many people chose chocolate, banana and vanilla all together? So, we've got to think about how many for chocolate was 45, wasn't it? Then we've got banana. Banana would be how many?
50.
Because banana is 10%, so it would be 15 children. And then our vanilla would be
15 because it's 10%.
15 again. Add them up, yeah?
Which is 75
Is 75.
children.
Thank you very much for the context, children. Excellent. Okay, you've got to remember, key here, I put a question at the bottom, what does the whole pie chart show in total? We know the whole is 150 children, and as we did yesterday, it was quite useful to think of the whole, go back to my chocolate bars, and if you're not quite sure, draw a bar representation, Okay, so it's at least then you can see, well, suddenly we're looking at 10%, so if we divide this up into tens, we know that will be 15, because the whole would 150. Okay, start thinking in the process of visualising that bar. Okay, we've got a second question to look at. So here we've got 200 pupils in Key Stage 2 who choose their favourite hobbies, so this time a different context. So we've got all our hobbies down in the key: walking, reading, cricket, swimming, dancing and football. How many pupils chose each hobby? So again, we've got percentages there. How are we going to work out? What did we do last time? We found what percentage first?
We found 30%.
Didn't choose 30%. How do we get to the 30%? What did we find out first? What did we find out first?
10%.
10%, yeah. Then we times it up, didn't we? Yeah. So if we find 10% on here, I think, then we can work out all of them here that we've got values. So 10% of 200. 10% of 200 is
20.
20. Okay, so therefore we've got here a section, walking, 5%. How are we going to do that then?
Half the 10%, which would be 10.
Okay, so we know then already that 10 children, I can write on here, can't I? Forget to do that. So 10 children like walking. Okay, so 10% we said was equal to 20 children. Okay, so reading then, we've got 50%. So what are we going to do with the information that we've already found out? Yes?
Would you half it because 50 is half the 100?
You could half it, yeah, you could. So you could take your 100, if you know that 100%, again thinking about your bar, so 50% is half of that, so half of 200 is 100. Sorry, that's looking like a 6. Okay, cricket, 15%. Yeah?
You find 10%, which is 20, and half of 20 is 10, because you're finding 5%, so you add 20 and 10 together, which is 30.
Spot on, well done. Exactly the same method I would use. Okay, excellent. Okay, then swimming, of course, is 20. Dance is back to 5, so it's 10. And football is again 15, so we're back to 30. Okay, what's special about these numbers now? We haven't got any other spare ones, so what do we now know about all of those figures? Yes?
More people like reading?
Oh yes, yeah, definitely. We can actually glean that information. Yes, so we can write some questions about that. How many people like reading? We now know the answer to that, yeah?
No, that all the numbers should add up to 200.
Absolutely. So to double check, all of these figures should add up to our total of 200 pupils. That's really key to make sure that you understand that. Okay, so that's a really good session. Okay, we're going to move on to your Chewy challenges now. So as I explained, Chewy 1 and 2, that's going back over problem solving using line graphs, but a special kind of line graphs because they're conversion graphs, okay? So Chewy 3 and 4 are looking at the pie graphs in particular. Some of the questions, as I say, talk about the angle. As I say, skip over those because they are a slightly different context that we haven't learnt yet, or some of you Year 6 might remember from last year. Okay, so have a go and enjoy those challenges.